So the probably one of the most important macronutrients or nutrients in general is nitrogen. And so nitrogen can do lots of things. It can stimulate above ground growth. It produces nice green color, which helps in photosynthesis. It can influence how nice the fruit is on some plants. And it can also help the plant use other nutrients that it does need. And so nitrogen is actually replenished naturally by bacteria that's in the soil called rhizobacteria. It stems from the word rhizome, which is part of the plant root, and legumes are famously good at fixing nitrogen. So taking nitrogen in the form of nitrate and taking nitrogen and turning it into nitrate for the plant to actually use. And so nitrogen can come from a couple of places. We can use it through manure, so natural fertilizers, or through chemical fertilizers. Phosphorus is also very important. Um, Phosphorus helps with strong root systems, can help increase seed yield, and then also it helps the roots take up water. And so the phosphorus used in fertilizer is usually comes from rock phosphate. Sorry, I'm tripping all over my words right now. And so we actually mine for phosphorus. Um, so, we will talk more about nitrogen and phosphorus when we talk about biogeochemical cycles. Um, but all of this soil formation will give way into our soil horizons, which we talked about. Um, our soil horizons start at the beginning where you have this organic matter at the top. And as you work your way down, you have less and less organic matter as you get closer to the parent material. And so it just goes in order, right? A, B, C. So the C horizon has like the largest pieces of bedrock, mostly consisting of bedrock, whereas the A horizon is going to have the most organic material below the O horizon. So we're back to this picture. The uppermost layer is very rich in organic material, and the plant litter is accumulating in this O horizon. And so as plants shed their leaves, perhaps even an animal perhaps dies, you end up with this decay and it ultimately breaks down. And so in deserts, the O horizon is totally absent. But in other soil horizons, you have a very, very rich layer, just like this here in the grassland, like I told you before. Um, Topsoil is dark and very rich in organic matter as well. It has, even though it has the organic matter, it tends to be nutrient poor because a lot of nutrients tend to leach. So they actually end up percolating down through the soil profile. So the B horizon is beneath the A, and these minerals that are percolating down are actually usually in the B. So if you look at like trees and these like larger plants, their roots will ultimately end up in the B layer because they're all the minerals that are there that they need. And our C horizon usually contains, like I said, larger pieces of rock. Most roots don't go down that deep, and this is where we usually find our aquifers. The organisms are super important in our soil composition, and so you have more than 1 billion organisms in just a teaspoon of soil. So there's lots of bacteria, protozoa, worms, all kinds of good stuff. And so the worms are important because they can help digest materials that make up humus. And just like my vermicomposting, and ants or other burrowing animals are really important because they can aerate the soil. Soil provides lots of ecosystem services. So you can take a look at this little infographic right here. But they decay and cycle organic matter. It prevents soil erosion, breaking down toxic materials, cleaning the water that percolates through it, and then soil aeration. So there's lots of things that the soil organisms can actually do for us. And some of these have a very symbiotic relationship with the plants that live there. So the mycorrhizae, like the rhizomes, like I was talking about, there's the rhizobacteria, but there's also these mycorrhizae, and these are the fungus that are on the roots of some plants, and they help plants absorb essential minerals that they wouldn't be able to absorb otherwise. And these mycelium can actually help the plant extend beyond where their roots will actually go.